Hello. Okay, my name is Mark Zadarsky. This is my thesis presentation, uh, the Electronic Assisted Astronomy Proposal for Future K-12 and Higher Education Courses. It's a content analysis. I'm currently going for my master's in educational technology uh, here at NJCU. With a concentration in STEM. I'm a former NJCU employee. I was once the lab tech for the Earth and Environmental Science Department. Now I am at the College of Staten Island, the chief observatory technician there for the college's observatory, and also the college lab tech for the Earth and Environmental Science Department over there. So let's begin. So first, we're going to start with what we're going to look at and what we're going to cover. Our research questions, data collection process, data analysis process, review of the data collected, results and conclusions, and how the results add to the body of research, uh, implications for people in this field, and the finally the suggestions for future study. So let's begin. Before we get into the study itself, I just want to cover real quick. What is electronic assisted astronomy? Um, so essentially, you're viewing uh, astronomical objects, particular faint ones, deep sky objects through a telescope um, with a camera, some type of software. Usually goes through a computer or it's a standalone system. And it also winds up in the end on a screen or monitor. In the picture here, this is the telescope I work with at CSI's observatory. And this was just after a night of doing electronic assisted astronomy with students there. You can see that in the corner picture here, we only had a few students, so I did not have the larger monitor there. But you can see that there's a nebula in there. It's actually called the Dumbbell Nebula. It's Messier 27. If anyone's an astronomer here, it's a catalog number. Um, so this is the idea here. So the difference here is you can see it in color. You can see it in great detail compared to the human eye, even if you were at a dark sky site. And you can have multiple people standing around it instead of one person being at an eyepiece at a time. It's good for large groups. So this is another way, if you have even larger groups, you can project it in many ways. You can project it on a monitor, uh, plasma screen, projector on a screen. One of my astronomy clubs, when we were working for um, the Passaic County, New Jersey, we did a group of like 300 people in a baseball field in Passaic County with an inflatable screen that was 40 feet across and diagonal. So we used actually a smaller telescope than the one you see in the picture here. But the images were blown up on a giant screen. People came with picnic blankets and whatnot. And we were able to discuss what we were seeing, which was kind of great. So it's adaptable to many different types of scenarios here. And this here is, the at Jenny Jump State Park. This is one of my clubs. I'm the observatory chair in North Jersey group. So this was one of the public nights here, and we had a large group of people. So we broke out the screens. We had about 50 people at a time. Again, the observatory has multiple huts. We call them huts. They're roll-off roof observatories on top of on the ground itself. So we have about 7 or 8 observatories, and this was one of them. Ours was one of them. Uh, Other benefits. light pollution is a problem. Human eye, especially in cities and uh, even bright suburbs, you can't see any of these deep sky objects anymore visually, or they're very difficult. Most of your education facilities, your schools, your colleges, they're all in, population centers, and they all tend to be lit up pretty bright. So this chart on the side here is an example of number one, this is the Bortle scale, a perfect, pristine dark sky site, Montana, maybe certain parts of Arizona, where you don't have anything obstructing your view, any light pollution, and all the way to 8, 9, which is the sky that we are in here in College of Staten Island, and so is NJCU, shares pretty much the same sky, and you can see looking out the dome slit. Um, yeah, it almost matches this shading perfectly. It's not even pointed exactly towards New York City. That's how bright it is. You can't really see any stars. Maybe the brightest ones, the very brightest ones. So that is one of the big benefits. The camera can see where the human eye cannot. The human eye can only really take an image in real time and has a certain level of sensitivity, whereas a camera, you can do a 30-second exposure and gather light over time, and then put it on a screen, and so you can get more detail, and it's in color. Um, the other part is the idea of a classroom collaboration environment. Um, Being able to gather people in front of a monitor is a big plus. So let's look at our research questions. We had technically four. There's three and one kind of one sub question. Um, Research question one: is there a relationship between the rise of EAA and amateur astronomers as light pollution increases? Are not-for-profit astronomy organizations, including EAA, as part of their educational outreach programs? Did they consider using online or virtual modality for utilizing EAA, right? And how did astronomy educators change the mode of instruction because of the COVID-19 pandemic? And research question three is a little bit separate, but it tries to tie the other three. Basically, the idea is we want to see what the amateur astronomer community is doing. Are they accepting this new technology? Because they're kind of the canary in the coal mine. They're kind of seeing where this is going. And are they using it for outreach purposes? And is that something that can eventually translate to uh, a higher ed environment, or or upper K through 12, right, or a 100 level astronomy course. So that's what we're the target audience that we're looking at here. So again, this is only exploratory study. It's a qualitative content analysis. Um, I wound up using the inductive reasoning method, and then the reason for that, this is a new area of study. There's not much published about it. The other uh, piece of that is, if it's a new area of interest, are there other aspects that we don't know about, maybe that are worth looking at as well? So we're trying to see how this evolves. It's a new evolving type of technology. Um, so I decided to do a purpose of sampling approach in particular. The reason being is I want to find people that have this knowledge already. They're specifically already experimenting with this. And so, again, the canary in the coal mine, maybe the wider astronomy community at large isn't using it, or maybe they are, and it's growing. Um, and we want to discover that, any kind of new trends. So we're kind of looking this again from a sense of curiosity. So we're going to, pattern recognition here, with inductive reasoning. So observe specific observations of pattern recognitions, and then we can kind of draw conclusions from these observations. At least we hope to, anyway. So the data collection process for questions 1 through 2A, we're going to use the Cloudy Nights message board, or we're using the Cloudy Nights message board. Um, it's the most recognized astronomy information sharing site in the United States, and it's also widely used in other parts of the world. Um, there are a lot of people, amateur astronomers from different backgrounds. Some of them are former professional astronomers. Some of them are in education themselves. Some people are retired. But they all do astronomy. They all have different levels of knowledge and experience, and they all kind of share it with each other, and they all kind of learn off of each other. Um, and this is a great example. Just the message board itself is a good example of constructivist type learning environment. In fact, where you have collaboration, back and forth discussions of honing your technique, trying different technologies, different softwares, exposure times. Um, what did they, if they did outreach, you know, what were their tips for other people who want to do the same thing. So it's a real, I wouldn't call it mishmash, but it is an interesting collection of individuals, again with varying amounts of experience, from the newbie all the way to the very experienced astronomers that run big observatories. So the conceptual framework is the technology acceptance model. So the TAM was, first introduced in the mid late 1980s by someone named Davis, and he basically, there was two aspects of the TAM: um, ease of use, easy is it to use the new technology, and um, basically how well does it perform, right? Does it usefulness, perceived usefulness? Um, so these are the two things that one has to weigh. Uh, is the perceived usefulness uh, a big enough weight versus the uh, perceived ease of use? And maybe that changes over time too, Um, other ethical, considerations we have to consider here. This is a members only forum. However, anybody can access the posts uh, with any computer on the internet. For instance, I'm a member of Cloudy Nights. I can post on Cloudy Nights. I can look at everything. But if I wasn't a member, I could log on on their website. Don't sign in to their website at all, and look through the posts and read what people say. You put them in internet searches, these posts will come up. So that's kind of free reign. It's just things like, using pictures from their postings and stuff. You might have to ask for intellectual property, but as far as like the knowledge base, it's there for everybody. Again, we're an exploratory study. Um, the subboards that we're going to be using in this are the electronic assisted astronomy, EAA, and the outreach ones. So these are the two boards that are pertinent to the research questions that we're looking at. Sample size, since it's exploratory, is 25 posts we're getting. We're looking back to from 2015 to present, generally. This technology goes back further than that, but we want to stay kind of current with the information. as much as possible. Research question 3 uses a combination of peer-reviewed articles and some online sources. Um, and that's a little separate, so we won't use Cloudy Nights for that one. So, data analysis process. Their first research question is the rise of electronic assisted astronomy used by amateur astronomers and light pollution as light pollution increases. So we're looking for, again, 25 posts. We're reading the post, each post 3 times. The reason for that is, you might be able to glean more information the more you read it, and get better context. Looking for specific words, EAA, or things that are like these words, right? Or in the spirit of these words. So it could be electronic assisted astronomy. Video astronomy is what EAA used to be called before um, it was called electronic assisted astronomy. Things like light pollution, ease of use, anything that kind of is um, in that spirit. Um, the Also, we look at the overall theme. We'll write some notes on that, and just some general notes of the whole to give us context. So basically, these keywords are what lead us to the posts, and we look at the notes and the overall theme to be able to understand how we want to code it. So basically, also we're triangulating the data with other sources, like peer-reviewed articles, maybe one or two of those, just to try to data check ourselves to make sure um, we're trying to keep some kind of quality here. Um, so once again, to look at the questions, a yes answer, right, to the question would constitute, yeah, they're using EAA because light pollution. The no answers, they're using it for other reasons. Like for instance, EAA could possibly they rather view on a screen versus through an eyepiece, or maybe they see more with EAA versus through a telescope, for instance. Um, so then you look, the overall theme. You write some notes in that for some context, and again, any other outliers, any kind of unusual, anything of note that you go back to, and in the notes are also links to the article if you want to, in my code book, to the exact post. The link is attached in the notes section, so it makes it very easy to go back and find it if you have to go and check it again for any reason. Or it's also searchable by other people. Um, the um, Again, the somewhat category is the piece of this where it becomes a little bit subjective, and the theme and notes and specific words really will help the coding process here. So research question 2, the yes no somewhat is very similar on that one. So the question here are not-for-profit organizations, including EAA, as part of their educational outreach programs. Um, Again, same sample size. Um, we'll read the post 3 times. So basically, there's some uniformity between all of this here. And the specific words, and again, electronic assisted astronomy, outreach, public are those keywords, right? Or anything, consider the theme and the notes for added meaning. Um, Again, triangulating the data with those peer articles to try to, confer some reliability again. Um, and again, this picture over here, this is an example of outreach that we do at Jenny Jump State Park at night. Again, depends on the size of the audience we expect, whether or not we put a large screen out, a small screen, because if there's a lot of visual astronomers, we want to keep it darker, and the screen actually adds brightness. It also depends if the moon's out. So if the moon is out, We might as well put the big screen because it's already affecting everything else. Um, so again, same with the yes, yes, no are pretty straightforward. They're using it for outreach. No would mean it's not being utilized. Somewhat is also more complex, and that's where you look into the notes and the overall theme, and you try to answer that question a little bit more, a little bit more context. So the sub question of research question two: did they consider using online or virtual based outreach at all? Right. This is something that they've done. Again, the reason why we're asking that is maybe we might want to use that in an educational setting in a school, right? Um, Same sample size, right? Read everything 3 times. Um, and then specific words that we're looking for, virtual broadcast, or anything like broadcast, right? Transmit, video, anything that Zoom, anything along those lines that are the are kind of like cousins to that term. And then easy for ease of use. Um, Again, we're staying with the TAM. And again, we consider the theme and the notes for any kind of added meaning here. Again, the same thing with triangulation of data. Um, so just an example of what this would look like. There's actually a very famous amongst people who do EAA site where you can log on. You can have a remote observatory. You can have a telescope in your backyard, um, and you can broadcast. So it's a Night Skies Network. I actually know the person. He's a member of one of my local clubs. He started this website up some years ago, and so anyone can um, get a membership, and then you'd also can get a everything's free, a membership to transmit if you want to broadcast something. And here, this is an annular eclipse back in um, October of 2023, and this was during the daytime. This was in Arizona, Arizona or possibly West Texas, but in that area, if memory serves. And people can log on, ask questions. There's a chat room also, and then so you can interact with uh, the person who's uh, doing the presentation. So, I mean, some schools have used this where a person has used the site and they've broadcast, and a bunch of students can ask questions and answers and things of that nature. So the infrastructure already exists. Um, and there's other versions of this infrastructure as well, but this is one of the more known ones to people in this community. And it is a valuable resource. Um, so this is something just to so you know what direction we're going or when we're thinking about that. Something else that might people would use is Zoom broadcast. So that's another piece. And speaking of a Zoom broadcast, here we have one right here. This was a public night that my club did in 2020. Um, we did a few of these, but this one was recorded on our YouTube channel. Um, so ideally, you use 2 or 3 people, but one person can do this. This was at the time our president Kevin Kennard was doing the planetarium part. So he works at a planetarium, so we were able to put a planetarium software to see where the telescope was pointing, and 2 other people, myself and Omar Radwan, would operate telescopes in our own backyard. And so we would show them what the telescopes are pointed at, and we talk about it and some question answers, and we'd have people discuss what they're seeing also. Um, But going back to data analysis, again, the same thing with the yes and no is kind of a 1 and 0. Somewhat is more complex, and then you would go back to your notes and look for themes once again here. And so the research question 3 is basically looking at astronomy educators and what did they do? Did they change their mode of instruction because of the COVID-19 pandemic? How eager were they to step out of the comfort zone of doing um, traditional astronomy labs or traditional activities? So this is a little bit different again. So the sample size was only 7 articles, or not that much on this that I could find. So that is a limitation of this study, just part of the study. I read them uh, about 3 times to try to get as many, much information and understanding out of them, particularly the parts that where those specific words and phrases, online, observing, activities, seminar. There'd be other ones too that collaboration. And this is where you more heavily consider themes and notes for looking for added meaning to these questions. And again, now here's basically the whole spreadsheet example. Um, did they do asynchronous online only? Did they do a hybrid or virtual scenario? Did they do anything in person? Again, the theme, words, phrases, and notes. Um, so then all that data is tallied and it's interpreted, to see how eager they were to make these changes. Again, since I was a sole researcher, it limits the accuracy of the data set. Uh, it triangulated the data with at least 2 other sources. Um, and the sample size is limited. Um, the other limitation here is researcher bias, right? Um, not me being the only researcher or the sole researcher. I try to be as unbiased as humanly possible, but the fact that I am a little bit attached to uh, this field of study uh, makes gives the impression of bias if there is or isn't. And that's something that has to be considered regardless. So, looking at the results and kind of connections here, is their relationship to the rise of VAA as amateur astronomers deal with light pollution, right? And so we had 7 out of 25, 17 answered yes, 5 answered somewhat, and 3 answered no. So generally, making a generalization here, um, again, it's a limited study. They're generally open to utilization of EAA under light polluted circumstances. What does that mean? So in this small group of people have, my interpretation is that they've moved away from eyepieces, and some, still like, will use an eyepiece, particularly for planets and moon, right? Those are the things I see in my notes, the bright objects. But the ones that they can't see in their home or backyard, they've used words like game changer. They can enjoy this again. They don't have to travel to a dark sky site to see their favorite objects. They can, and some of the ones that have answered no altogether, um, they use EAA because no matter what, they've abandoned visual astronomy and they can see more. Um, they can see more through their telescope. Sorry, through their camera and software than they can through a telescope. So they've put their eyepieces on the shelf, never to use them again. Um, Again, our nonprofit astronomy organizations using EAA as part of their educational outreach programs. We have, out of 25, we had 23 said yes. Uh, Two subjects answered somewhat, and nobody answered no, which is um, pretty interesting. Um, so, basically leaning towards the nonprofits are inclined to use this, particularly in the more modern posts. After COVID, this seems to have picked up quite a bit more. Um, so what does it mean? So most of these uh, members, they belong to astronomy clubs. Not all of their members use EAA, but a few of them tend to. A handful of them use it, and they're always there at these outreach events, or they're specifically asked for during these outreach events. Either they're doing an outreach for a school, or it's a public outreach, and people come to the club's meeting area, and they observe with the club via screens. So there is a strong leaning that this is going in that direction. um did they consider using online or virtual based? Out of 25, 20 answered yes, 3 answered somewhat, and 1 answered no. Um, so it looks like from those people that have adopted EAA, have also uh, adopted the use of um, broadcasting also. Some of it was from the COVID pandemic. Some of it is, a lot of it on the message board is through Night Skies Network. Apparently, a lot of them do that, and they like that. It also allows them to, looking at my notes, allows them to share information with each other when they do a broadcast, and they learn techniques from each other. Again, a constructivist type of learning approach, even if it's from the sample and not necessarily the students, but it's the same idea. So here's an interesting one. Out of the seven um, papers sampled, 6 chose to fully utilize online instruction. So online asynchronous due to the COVID pandemic. 0 chose hybrid or virtual, and only 1 was in person. So the predominant form of instruction was online. So there was a willingness here to break a traditional mode of study. So I mean, the ends justify the means. Maybe that actually necessity is the mother of invention. So they were kind of forced to do this. Um, so this maybe points to the direction. Well, if they adapted with this type of technology, they're open to adapting to other types of technology. Maybe this is again something for a future study with EAA. Um, would you know would this work in a higher ed environment? Would this work in a K through 12 environment? But the limitation of this part of the big limitation is the small sample size for this particular sampling. So how do these results add to the body of research? Um, so again, these studies haven't been undertaken before, so this is kind of new, an emerging technology. Um, yeah, it's only been broadly used in recent years, and it got a boost from the COVID pandemic, most definitely. Um, but this study can work as a foundation or a starting point for others to do more detailed studies. So here on the left, it's a little piece of reference to the pictures. This is one of our astronomy nights. This is at near the end, and so we had astronomy club members just looking at and just actually discussing the interaction between 2 galaxies, Messier 81 and 82. And they're in the part of the sky where the Big Dipper is. So the telescope is out of the picture. It's pointing kind of towards the northeast at this point. Implications of the study. Um, so there's definitely an emergence of a new trend, uh, in astronomy education and outreach, um, at least on the amateur side. K through 12 schools are asking for this. They've had a parent and kid come to one of these events, and then they want them to come here with the video camera and the telescope, and they want to have this type of modality. They're interested in that. And so there's a potential for adoption of this technology, and the labs can be enhanced. So again, more needs to be studied, perhaps a live study. Um, Again, going into that suggestion, future study. Uh, Probably the next step is a wider content analysis, with uh, larger data sets than we use for this initial exploratory study. Using multiple coders, you can, lessen the chance of error, better intercoder reliability. Um, and then maybe later a doctoral level study with live subjects, would have to go through IRB and, be done in an ethical manner. And that'll be a more personalized input, and a deeper understanding of technology and education. For instance, you would have, just a hypothetical, um, a few study groups where over multiple years, or right, a few, or multiple seasons or multiple semesters, with some labs utilizing EAA and some labs just doing visual, and then you would ask uh, the subjects what they thought of each lab and what kind of knowledge they gained out of each. So once again, a conclusion here. Um, Electronic assisted astronomy, it's being used by amateur astronomy clubs, amateur communities, and it's being used for multiple reasons. But the main one is, you know, getting around light pollution, which is getting worse. Um, there's evidence that it's already being used in educational situations, by local astronomy clubs. Um, they're being called to schools. Uh, they're being asked to present, whether it's virtual or in person. Um, there's some evidence that astronomy education is going to change modes of instruction during the COVID-19 pandemic. Again, this is a correlation causation type thing, but at least it shows that maybe there can be a connection tangentially. Uh, they accepted that change. Light pollution is kind of forcing things in this electronic direction, especially again around heavily populated areas. Um, and we're hoping that astronomy educators may be open to incorporating it into their curriculum. And so once again, uh, more of these in-depth studies are going to be needed, to really know for sure. Um, like the two we mentioned in the last slide. But before we go, and before we open ourselves up to questions, I'd like to show everyone a video, or a compilation of videos that I've taken utilizing electronic assisted astronomy in different situations. And so I'll narrate these as we go through them. So this is one of the first quarter moon, and it's actually very. I'll take the sound off so I can actually do the narrating. It's very good to have multiple um, videos. The reason for that, I for instance, I've been building a library for the past few years. Um, I can show people the moon in any phase. If there's an event, and it happens to be cloudy, I can bring up the moon phase, for instance, of the day we were supposed to observe, and at least, stop, go forward in the video, and talk about it in more detail. And so now this is a deep sky object. This is actually a very famous one. If anyone is familiar with the Hubble telescope, Hubble's got a lot of images. If anyone's heard of the Pillars of Creation, this is in just above the constellation Sagittarius in the night sky, in the summer night sky, actually. And these are called the Pillars of Creation. So you'll see a Hubble image, a very famous Hubble image. You put that that Google search in, and you'll find it. But the reason why they're called the Pillars of Creation are that this is a place where stars are being born. And so, and right here, an astronomy student, lab student, would be viewing this, and maybe would, they've had this um, in their lecture part, and then in the lab, they get to describe what they see. And they're also able to talk with other students and uh, glean new information, in a constructivist manner. This is a recent one. This is from last October. This is Comet Shushishan Atlas, was in the news, if everyone remembers. And so this is just after it rounded the sun, and it's on its way out. And this is, again, video. This is going to be strange, but up is towards the right, down is towards the left. That was done on purpose to be able to capture as much of the comet's tail as possible. And you can see that there's things streaking in front of it. It could be airplanes or satellites and things of that nature. But also, what you want to look at here, and this is what we would tell students, we talk about orbital motion. And, you look at, planets from one night to another, you really can't tell movement. But here I'm going to go back, and if you look at the comet very closely, and so I'll move it back in time. So these two stars as a guide here, my pointer is. And notice that the head of the comet is moving towards this star here. And now going forward in time, again, the comet's on its way out and away from the sun. So sunset is towards the left. You can see the comet is moving up and towards the right a little bit, closer to this star. And so in that little bit of time, you're able to see a change there. This particular one is one of my favorites. Last year, I was fortunate enough to go to Burlington, Vermont, to see the April 8th, 2024 total solar eclipse. And I was set up with a telescope and a solar filter and everything, and I recorded the entire eclipse event. And so we're not going to go through the whole couple hours, but we're going to speed up here. This is also a teachable moment, um, where you can see the moon's disk moving in, covering up the sunspots, which one's in the middle and one's at the 11 o'clock position over here. Um, yeah, moving in closer, further in. But this is something, again, I have recordings of this around. They're here. They're teachable moments. Again, you can save these clips and use them for future use. And we do that in our observatory in Union College, for instance. We have, matter of fact, I gave them a copy of this to use. And this is, totality is just happening here. I just took off the solar filter, and about an hour and 9, you'll see the corona. But you can see over here, uh, that is up at the 10 o'clock position, and down here at 7 o'clock. These are solar flares or prominences, right? Coming at the edge of the sun here. This is something you wouldn't ever see except during an eclipse. And so right now I'm about to adjust the exposure, right? And you'll be able to see the corona right after this. I increased the exposure time a little bit, and poof, there it is. I'll just adjust it back down. And so here it is. This is totality now. So this is the corona, the outer atmosphere of the sun, that you get to view here, which is really cool. Again, it's something you only get to see during eclipses. And this one only lasted, where I was, 3 minutes and 30 seconds or thereabouts. in Burlington, Vermont. The next one, I believe, will be in 2044. So recording this is kind of a important thing. I had a temptation to broadcast. I was asked if I was going to, but since this was my first total solar eclipse, I was told by people who have gone to these before not to. Record it is fine, but you want to be able to experience it for yourself. So that's important to know. However, capturing the experience for others later on, again, this is a useful thing. Uh, this also can be shown in a classroom and used year after year or semester after semester. Um, that this is something that you yourself actually went to. And here you can see the sun, sorry, the moon pulling out in a way. And so this is just about to end. That's about it. And very good. We're done. Um, so I would like to thank everyone uh, for coming. Um, make sure this is there. We are. Uh, these are my references. These are just the references I used for the PowerPoint presentation and the slide here. And thank you.